Alright, kids, I guess this is the culmination of it all. I don't know what this or life's all been leading up to, but I guess this is it. Alright, here we go. Say you got a force vector, and here's your grid axes. Is 8 here, and then -5 here. They're in opposite directions and they're perpendicular, so we can subtract them. So this is just one dimension. So what do we got here? Oh, 3. Yeah. It's pretty gnarly and metal. Pretty metal. Okay, so how about if you got 8, 3? I mean, flip those. That doesn't make sense. But that's an 11, and you all get that, and that's good. And you can do this with the vertical, too. So, now what happens if you want to add uh, 35, what is this? 112. We'll make this 112. 112. Boom. 19. And 5. What? That's 270, right? Yeah, 180. Yeah. 290 degrees. That's 5. How are we going to add that mess? Well, here's the magic. I guess. This is kind of like the moment where you're lying, you're about to die. You think, man, I did things. When you finish doing this will be one of those things when you think back on it. So this is a gnarly mess, but you can handle it. I've always been able to handle it. So let's handle this. How about all you who think you know your math, you pause and you do this, and all of you who don't think you know your math, you're wrong. You know math, you're in physics. If you don't know your math, the best way to do it is doing it. So everyone pause the video and attempt to add this. Attempt. Alright, here we go. If you couldn't read my writing, or you didn't know how to do it, here it's time to learn how to do it. So we're going to make each of these components, and we're gonna add all of those components together. X's with the X's and Y's with the Y's. Here we go. So first one, 12 35 degrees. That's going to be 12 sine of 35 is going to be your Y, and 12 cosine 35. That's going to be your X. So plug those in. Oh, we're rocking. 9.8. Then Y, 12 sine 35, 6.8. Okay, here we go. Next one, 19 cosine 112. Look, it's negative. You're on that chord. You're in that quadrant. Like, I was really worried it wouldn't be negative. I was concerned because that'd be embarrassing, you know. All right, 19 sine 112. This should be positive. We're hoping for the best. Oh, doing good. All right, now. What is that, 5? That's a 5. 297? Is that a 297? It looks like a 297. Alright, here we go. 5 times cosine of 297. You know me. Oh. Yeah. whatever. I mean, like, is anyone even going to watch this, or am I just speaking into the wind, the void, man? It's kind of like being alive. You're just talking to the void. Because I mean, no one really knows you, and they pretend like they do, but they don't, and they don't care. It's kind of like a cat that eats you after you die. Here we go. Here we go. Here we go. Whoop. Look at that. Those are our X and Y. So X should be positive, being that it's over here on the positive side, and this is on the bottom, so that should be negative. Always check, because I make lots of mistakes, and I'm Mr. Hicks. I make lots of mistakes, and I'm Mr. Hicks. Okay, we're not done yet. Let's add these together. 9.8 plus negative 7.1 plus 2.2. That's 4.9. And this is 6.8 plus 17.6 plus negative 4.4. I should have just subtracted that. It would have saved 2 key presses. Alright, now do you see how part one we just did part 1. Now we're gonna do part 2. So we need to find our angle, and we got what the result of that mess, that gnarly mess of metal physics, is something with 4.9 for the x coordinate and 20 for the y, and it is this line from the origin to there. So what is this degree? So we got our components. We make a right triangle. We do trig. You know trig, so you know vectors. You know Pythagorean theorem, so you know vectors. So here we go. 4.9, 20. So on acid. Here we go. Arctangent of 20 on acid. Whoops, I did that backwards. I think I can't remember. That equals theta, and theta equals, whoops, wrong button. Oh, I'm getting off the screen. Sorry. 20 over 4.9. That's 76 degrees. 6 degrees, so this is 76. Now, what is the magnitude? Here we go. We're going to use that old Pythagorean theorem. 4.9 squared plus 20 squared, square root of that, and that will equal the magnitude of our thing. It's 4.9 squared plus 20 squared equals 42, whatever. Whoops. Oh, 20.59. So here we go. And I mean, like, you're pretty much doing vectors. You just gotta know. You gotta apply some things to like a general thing. So first, for your components, your magnitude times sine. Whoops, I actually want to do cosine. Theta equals x component. Remember that. So let's do y. We switch the cosine with the sine. Remember that. So m sine theta is y component. Yeah, that's how you abbreviate component. I had dreams once. And now what else did we do? You can just add your x and y components to get your resultant when you add them, and then to get your magnitude, just do square root of x component squared plus y component squared, and that equals magnitude. Like with these formulas you can get anywhere. And then angle, it's one of the, it's just use one of your trig functions to find it. You just make a right triangle and it's normal. There's not really anything new here. It's just like you know these equations. You've dealt with them, hopefully, maybe. And you can do it. You'll live, and maybe living at all is meaningful and beautiful and wonderful. Like just doing your vectors, maybe that's your point in life. Maybe that's why I know. I mean, like, why? Okay. I guess I think it's time for my trademark catchphrase. Hicks out, I guess.